Well, welcome to YYCJS. I'm Eric, and that's David. And then we've got two guest presenters today. So Kevin Barabash, right? Perfect. He's a local JS dev currently working for Smart Technologies. He's going to be talking about FRP. And then Julian Lam, all the way up from Toronto. He is the co-founder of NodeBB, right? NodeBB.org. It's a online forum management software built in Node.js, and he's going to be talking about scaling Node.js. So both really interesting talks today. So where you guys are at currently, like I said, help yourself to a beer. Sponsored by Village Brewery, so give them a shout out if you want. That'd be awesome. You're also here located in Assembly, so this is a co-working space here in Calgary. Great space if you're looking for a desk. I guess beer, the money and stuff is provided by Petrofeed, so they're a local oil and gas startup here in Calgary. And let me see, did I miss anybody else? Usually we have cues. So I guess, yeah, last month Dave covered testing. I was sick, so I think you covered testing, right? Yeah. So you can find all the material up on our GitHub. Just search YYCJS, you'll find it up there. YYCJS.com has links to all the stuff. And then next month is a little bit TPB, so we're taking kind of calls for that, but we'll come up with something interesting. And without further ado, I don't know who's up first, Julian? Yep. Kick it off.
Okay, so thanks for the introduction. I'm Julian, and I'm going to be talking about scaling with Node.js. Also known as a better title exists elsewhere because, honestly, I think a better title does, but I couldn't really think of one. So, I'm Julian, and I'm the co-founder of NodeBB. And NodeBB, essentially, it's just forum software but built for modern forms. So you can imagine forum software. It's been around for about a decade. Code isn't all that new, and a lot of the modern web aspects we're used to aren't really run with forums. I mean, imagine trying to use a forum on a phone. It's all, you have Japan, you have Zoom. That's what NodeBB aims to solve. So I'm from Toronto. Yeah, the guys who called the army to shovel some snow because we couldn't do it ourselves. All for a low, low price of going to watch the Leafs play, or the Leafs lose, rather. NodeBB. I'd love to talk about it at length, but it's not what I'm here to present about. So if you want to approach me to talk about NodeBB, just come to me at the end of the presentation.
Can you put a 5-minute demo at the end?
I could.
Depending on how long.
Or we could come tomorrow at demo camp and I can do it again.
Oh, I have a quick question too. So this is kind of a quick plug, but for you guys, NodeBB, is that a free product or are you guys charging for it?
Yeah, NodeBB is completely free. So GPL v3, free and open source. We just can't sell it. Just like, yeah. It's GPL v3. So yeah. Cool. I like a lot of forums out there actually. We don't go with the paid subscription model like we like default or keyboard and so on, where we go with a free and open source model where you can build yourself, and you come to us for professional consulting and so on. Alright, so anyways, scaling with Node. It's a little bit different. How is it different? Because now we're working with JavaScript on the server side. So this brings about a new breed of developer called DevOps, basically. And you know, a lot of you may actually just an informal poll here. How many of you are working with Node.js here? Not okay, a fair amount of you. So the rest of you, I'm assuming, are either not programmers or are working with JavaScript in the front end, right? So what we have here is empowered developers working with JavaScript on the server side. And that's really scary because that's an entire new branch of stuff to do, essentially. Deployment is pretty damn hard. And the fact that you have developers who normally work with jQuery and work with client-side JavaScript, trying to deploy things to Heroku or Cloud9 or OpenShift, and you can do this just by Git pushing. It's a whole branch that a lot of developers aren't familiar with. That goes hand in hand with scaling as well, because a lot of front-end developers don't even bother with scaling. They think, okay, I'll just not use the $, open bracket, close bracket as much, and then at scale, right? Not quite. Basically, that. That was me when I first started scaling about a couple months ago. Who remembers the Intel Pentium processor? Most of you probably have one, maybe. If so, get a new one, because you have the Core 2 now. So I've had all the Pentiums from the original down to the Pentium 4, and I always used to joke that I could just go without a heater in winter because it ran so damn hot. So basically, it was introduced in 2000 and was supposed to go up to 10 gigahertz. It didn't quite get that far. So it got to about 3.8, and then it started, Intel started running into heat dissipation issues. The key here is that Intel marketing really went full hog with the whole clock speed thing. When a layman is trying to buy a computer, you think the CPU, clock, memory, memory and hard drive space, and the loaded software and all that. And it's really confusing. So the Intel marketing went and said, okay, we'll just basically equate CPU with horsepower. And that's what they did. And so it's always what more and more CPU, more and more higher and higher clock cycles. But the problem with that is that they ended up pouring millions of dollars into R&D just for that last 100 megahertz. But it wasn't really worth it, was it? Because in 2005, AMD went and put 2 cores into a chip, and bam, they were beating. And then Intel went ahead and put 2 cores into 1 chip in 2006. The whole point here is talking about horizontal and vertical scaling. Horizontal scaling, basically, more servers, more nodes, more stuff to answer queries, more stuff to do calculations. Whereas vertical scaling is better servers. So, more CPU, higher memory, that sort of thing. But when we're talking about programming, what do we mean at the code level? Code level wise, we're talking about horizontal scaling being more processes. So more threads, more workers, that sort of thing. Whereas vertical scaling would be more efficient code. Technically, that's not what horizontal and vertical scaling means. I'm talking about code level, so work with it. So myth and misconceptions about nodes specifically is that nodes event loop scales much better than anything. I don't have to worry about scaling. And if you work with JavaScript, you understand the event loop. Even if you don't know it's called the event loop, or callbacks here. So the idea of being able to start an AJAX call and then go ahead and do something else, do some number crunching, or manipulate it or something like that. And while the AJAX call takes some very time and comes back, then you can handle the response and the callback. That's basically the power, because you take that and put it on the server side. Where I come from before Node.js, I was working with PHP. So I would make a call, and if it took a couple seconds, okay, so the PHP worker just kind of idles there while waiting for them back. So I can't really do anything. I can't serve any more requests, that sort of thing. So Node.js is faster in that way, but it's a mistake to think that the event loop is some silver bullet, be all, end all, and solve all your scaling problems, because it doesn't. Node is great for certain things, but not. And that leads to my second point, which is that Node is a hammer and everything is a nail. If people try to use Node.js to build, let's say, image manipulation or number crunching, calculating pi to the millionth digit, that sort of thing, you're going to run into issues where Node isn't any faster than PHP because it's still an interpreted language. It's just JavaScript. And when you're talking about, and that comes down to how fast your CPU is. But when it comes to I/O-bound processes, making requests, AJAX calls, disk writes, that sort of thing, Node really excels at that. And that's where the power comes in, where you can do hundreds, maybe thousands, I don't know, of disk writes, all more or less concurrently, whereas, if you with PHP, you get a disk write, that thread just kind of blocks until it's done. Lastly, I could just buy a bigger machine or more machines. And well, if you're part of that company that has enough money to buy a 64-core machine or 64 single-core machines in server farm, well, then kudos to you. But I don't have that kind of luxury. I have one server with 1 core. And I got to scale this in some way, especially with startups where funding is a little bit tight. NodeBB had a customer called Hashdog. Has a customer called Hashdog. Basically, they're run by a foundation called Gallminers, and Gallminers is cloud Bitcoin mining. That's another topic, but the whole point is they had a really huge discussion forum, and they were using PHP or something like that, but they didn't really like what they were seeing. It was really old, didn't work out really well for them, so that's where we came in. So they came to us and said, your forum doesn't scale, but we need to be able to, we like your software. Okay, so I went and put them onto a dedicated hosting instance of ours. What I found out was that, I was running into 10,000 page loads per hour, which is about 7.2 million per month. If you extrapolate it, easily 4 times that on announcement days. So, and they had announcements every 2 weeks, or every week near the beginning. So what happens when people are really excited about announcements and they want to be the first to respond, they press F5. They press F5 a lot. And when that happens, and when your Node application is doing full loads as opposed to our single page app, then you get easily you're loading all those assets that you weren't loading before, HTML templates, style sheets, and so on. Obviously, there's a problem here because our software just basically died under the load. And what we had to do was really quickly, because this was already in production and failing and falling over, was to scale quickly and easily. Oh, also, we didn't know anything about scaling back then. So we had to do all this on the fly. First step is always information gathering. So we need to know what exactly is the problem here. So we used the top utility to look at whether the problem was with the database layer or with our Node application. And just by using that, we can find out, based on CPU utilization, you can see whether problems with your application or with the database layer. Specifically with Ashdoc, they were using Mongo. And Mongo is not that good when it comes to scaling upwards. Although the next version, which is due out next year, is supposed to solve a lot of that. So we need to fix a lot of that as well. From there, we also looked at the node profiling built in, which gives you a v8.log file, which really goes through step by step. Or we ended up going near the end, we ended up just putting in timers and just measuring the articles and optimizing that way. If there's a database layer, of course, we have your utilities. Specifically with Mongo, there's always Mongo stat, which shows read writes and queues. You want to reduce your queue, of course, and of course decrease the number of reads and writes. Obviously, you want to have no queue at all, but depending on your Mongo instance, you might have to. The end tool suite is also pretty good at determining what goes on with your Mongo instance. Okay, the biggest improvement by far was with express.static and res send file. So it's easy to get started. I built NodeBB, and it was supposed to just serve static assets. So we're talking about JavaScript, client-side style sheets, templates, and so on. They were all being served through express.static, which is fine. It works great because you have no dependency. You're just using Node.js, you use the Node app, and everything runs. The problem with that is that everything is being served by Node. We're talking, again, style sheets, client-side scripts, and all that. And you don't think it adds up, but we're talking, you think about all minifies about 900 kilobyte JavaScript file, which is, it takes about a fraction of a second to load. And then multiply that by all the assets you're serving. Multiply that by the number of concurrent users you have, and you can see why the one instance, the one node process we had was basically falling over. It was too busy trying to send files over statically. I have a bit of a tidbit of information here from SitePoint saying that the average page rate floated by about 30% to about 1.7 megabytes. That's huge. More style sheets, a little bit bigger in style sheets, just so that we could do more responsive work. But 96 individual HTTP requests. That's like individual image assets and so on. NodeBB itself uses about 50 or 60, so that's not too bad. But you imagine, Node serving 96 individual assets. That's pretty huge. The solution here is pretty simple. Nginx. So just 10 lines straight into our as a front end, and basically your request matches one of those static assets as matching this regular expression, so the images, languages, sound, and so on. Then it loads the file and bypasses the Node.js completely. Otherwise, it falls back to the named route, which proxies it to Node.js. If it doesn't match the regular expression, it proxies it to Node.js. So it's pretty transparent. And even if Nginx went down, actually, no, if Nginx went down, things would go haywire, but hold that point. Yeah, you don't technically need those two, but the fact is, with just 10 lines of code, you can really, you can just reduce all those calls to Node by a huge amount. Okay? Because the key here is when you're scaling, you want to pick the low-hanging fruit. You want to find the most effective solution with the least amount of time and effort and so on. That's one of them. Secondly, scaling horizontally. If you've never used a cluster module, it's pretty simple. It's pretty experimental, so it's probably going to change a bit, but it's working pretty well in production for us so far. It's, 4-6 lines technically, and if you're a master, then you fork some processes. If not, then you run your app. It's pretty simple. So using those 6 lines, we managed to go from one process to however many we had. which for this client we eventually went to 16. And the overhead is fairly minimal because you can see it's pretty small. Again, 6 lines, but being able to scale up to 16. 16 cores specifically. Because the problem with Node, well, not really a problem, but with Node you have one CPU, or you have one thread rather. And unless you use cluster to branch it out to more nodes, then you're pretty much stuck with the one thread. All right, now the touchy subject, refactoring. So scaling vertically, I hate refactoring. I hate looking at my code that I wrote, and even worse, I hate looking at code I wrote 2 months ago. Okay, so you want to go ahead and reduce the number of blocking calls and synchronous calls and so on. So everything that can be going off to a third-party solution, you may as well. Sending emails and so on. The example here that I like to talk about is password hashing. So we use a bcrypt library for password hashing. Nice and secure. Even I don't know what the password tables are because we use a bcrypt. Problem with that is we're using 12 rounds, which is pretty secure, except that every time you want to compare a password, it takes about 4 to 6 seconds. So 4 to 6 seconds of a blocked call, basically, and then your navigation is not responsive for those 4 to 6 seconds, which is pretty huge, especially when you have 1,000 users working or trying to access your site at once. So from there we just fork out to a separate thread just for hashing passwords, problem solved. Any asynchronous method should be avoided. Use callbacks, and this is usually a problem with beginners, because they like to go with synchronous programming. You come from PHP, you think, okay, everything is in one nice flat file. I understand everything. I don't want to use these callbacks, but the problems become apparent when you try scaling because everything is synchronous and you're in the thread blocks. If you're bottlenecked to the database layer, and there was after we started scaling with our code and horizontally, we found some problems with our database layer, specifically because we have the one Mongo instance, and now the problem has shifted from our code to the database. So we need to go and eliminate any slow queries, add indexes, and refactor our database abstraction layer, because we do work with an abstraction layer to talk to Redis as well as Mongo. Our abstraction layer is actually more suited for Redis than Mongo. So there's better refactoring to be done there. And batching is also really important as well, because anything that's not critical, we're talking about increments or timestamp updates, you can always defer it, even just by a second. Batch them all within a second and then write to the database, as opposed to writing 100 times per second. You reduce the number of writes and queues and so on. So in summary, you make sure you do your research. Make sure you're not spending hours and hours optimizing a function only to realize it doesn't actually impact your application at all. Eliminate any synchronous or blocking calls, use all the CPUs you have, and basically scale horizontally and vertically. Because you can scale one way or the other, but eventually you run into a wall where you either have enough money over time, or it's just not worth it for you to scale all the way. Any questions? Comments? Flames, trolls, etc.? Yes.
Was there any shared state between threads the different processes that you worked on?
Any shared state? Yeah. Okay, so the question was there any shared state between all our processes and threads? So when you scale out horizontally, it's you do have to worry. You don't have to worry too much about sleepy sessions and so on if you use something like Redis as your session storage. But there was not much that we had to do actually. It was mostly things like pre-compilation that we had to sequester only to the first worker. Technically, I should have used grunt from the beginning, but I made out. But so then I had to work around that. But in the mean, when we scaled it horizontally using cluster, that was it. We didn't have to work out too much about that. Any other questions?
Yeah, I got one. Are you who are you guys hosting with? Because I mean, I'm assuming obviously this isn't on Heroku. You guys are running somewhere else.
Yeah, we're using DigitalOcean. And yeah, so DigitalOcean makes it really easy to get started because it's $5. And it's pretty good uptime for $5, and you kind of get what you pay for. I mean, if it goes down, you can't really complain. But that's that.
And so that kind of makes sense for why you would use Nginx, because for people who aren't familiar, you can't really do that with Heroku, at least not directly on Heroku. But as why not?
Well, we could always use a CDN for serving static assets. The problem with that is it doesn't really work with our overarching goal, which is to have something self-contained. So NodeBB itself is a free software that you can just download onto the server, you can get it to the server, and then you have your node instance running. So requiring a CDN layer is an extra step for setting up that we really want. But of course, it could always be optional. But at this point, it was anything that we could do that could benefit both the client and the open source project, we would prefer over with the CDN layer.
Nice. You mentioned that you scaled up to 16 cores for all the cores on the same server.
Yes. Okay, so the question was, so is there any?
Yeah, and a follow-up question like, are you able to scale across multiple server nodes with your current architecture?
Right.
If not, what would you do?
The question was, am I able to scale up to multiple systems beyond the cores on the physical machine itself? And using the cluster module, no, you can't do that. You can only scale out to as many cores as is available on the system. Technically, you could spawn 32 processes for 16 cores, but it wouldn't really help because you need 16. If I wanted to scale out more, and this is something that I would do for the client, because every time they have a launch day, they get 4 times the amount of traffic. So I want to spin up a couple other small servers. So you would use AJAX proxy as another layer in front. As a load balancer, the users would hit AJAX proxy first, and be redirected to the individual servers next. And then it's pretty transparent. They're pretty sort of separate in that way. So even so much that you have to worry about.
Can you get sticky sessions that way?
Yep. If you use Redis, well, we're using Redis for our session storage. And as long as, I mean, there's some more you can do with Redis sharding and so on, but or Redis clustering, but that's beyond the scope of this presentation. But yeah, if you use Redis for sessions, that's pretty much handled transparent.
Do you have any performance comparisons to Node PHPBB? I'd be curious on, I'd be just curious, right? Like they had to run, at least at Walmart, they had the same thing, and they spun out 25 server instances for Black Friday, and was kind of bored with running Node, where the Java version had to have like 250 running to barely handle all the traffic. So did you ever make performance comparisons?
We're too busy scaling to make I really wish we did, and I think I do have some, but I don't have them on me right now. Sorry.
Oh, okay. Good to know.
Anyone else?
How do I make money? Okay, so the software NodeBB itself is free, as you imagine. And the idea behind that is to have widespread adoption. So think WordPress model. So you have people who set up their own WordPress, and then maybe they run into trouble, or maybe they want a custom theme or a custom plugin, that sort of thing. We also do dedicated hosting. So you don't want to worry about the tech aspects of deploying and maintaining the server. You come to us and we do it for you.
Basically go through all the pain you already went through.
Basically,
What you talked about.
Cool.
Cool. Thank you.
All right. Thanks.
Right, I was going to do a break. I did notice that on the video, the break is always a little bit of a dead space, so I'm just going to put a video of my favorite computer scientist on, and for 10 minutes, we'll grab a beer, and then we're going to bring Kevin up. Thanks.
We'll be back in just a sec to set up.
Yeah. Cool, thank you. All right.
No. Yeah.
Check. Are you still here?
Well,
I don't know. You want more, right? We do use CLS.
All right. 10 minutes. Now we have Kevin here speaking about functional reactive programming, which I had to watch a presentation to actually get how powerful the whole thing is. So I'm really looking forward to it because it's a pretty new concept, but it's also really powerful. So, Kevin? Go ahead.
Good evening, everybody. My name is Kevin Barabash. I'm a software developer at Smart Technologies for probably the next week, and then I'm unemployed. Anyway, yeah, I kind of stumbled across functional reactive programming. I like to watch a lot of videos of conferences and talks online about programming and whatnot. So the one I was watching was from an engineer at, I think it was Netflix. He was talking about functional reactive programming, and it was kind of an interesting way of thinking about how to deal with events and such. So before I get too much into kind of the nuts and bolts of things, I just want to talk about general data types. And so there's kind of two axes here, and I probably should have labeled them, but in this column here we have like single pieces of data, and then in the second column you have multiple pieces of data. So and then the first row is like synchronous, so you call a function, you get that one piece of data back, or you get that array of data back. And then the second row here is asynchronous, so you might call a function, you get a promise back, and then at some time in the future, that promise will resolve, you'll get your data, whatever that value is. And so there's this missing box there, and what goes into the box is something called an observable. So the concept here is that instead of getting a single piece of data back at some point in the future, you could get multiple pieces of data back over time. So you might get one piece of data, and then a couple seconds later another piece of data. So they're similar to to event streams, where maybe you're moving your mouse around and you're getting events from that source. Okay, so it's an observable or a collection of values that can be observed over time. That's cool. But functional reactive programming kind of takes that a step further by providing common functional programming methods like map, and filter, and reduce. Maybe some of you have used map and filter with JavaScript arrays. You can do array.map or array.forEach as another way of kind of looping over data. But it goes a little bit further and adds a lot of other handy methods like throttle, debounce. So those are different ways of kind of controlling how quickly the data gets to you. Zip and join, it's a way of taking multiple streams of data. So you might be getting events from the keyboard, from your mouse. You might be getting events from an event emitter. Who knows? And so you can combine these to kind of to create new types of events. So I'm going to go through some actual concrete demos here today to kind of explain this in a more concrete way. And the other cool thing is that you don't have to worry about cleaning up your event listeners. If there's an actual end to your event stream, or you specify, oh, I'd like to only take the first 10 events. Once you get those first 10 events, it does all of the cleanup of the event listeners for you, preventing memory leaks. So that's kind of cool. Okay, so you can use it with arrays, events, callbacks, promises. So it's a way that you can actually combine a lot of these different things together. You might actually have some complex logic that you want to describe that involves, maybe a callback from an AJAX request and maybe an event from the keyboard. So one very simple example could be, a person's typing and they want to do, you want to do a search as they're typing, but you don't want to overload the server with too many requests, and you want to filter out what might be duplicate requests if there's extra white space that the person's typed or whatever. I'm actually not going to go through that example because it's one of the ones that's posted on the YYCJS website. So speaking about RxJS, I'm going to talk briefly about two different frameworks. I have most experience with this one, so my demos are going to be in RxJS. So it stands for Reactive Extensions for JavaScript. So originally, Reactive Extensions was a library framework that Microsoft put together. Netflix really loves Reactive Extensions. They use them extensively on both back end and front end. And there's a link to the webpage. I'll get the slides out afterwards sometime.
Sorry?
I might actually just click on this just to show. Okay, this isn't very exciting, so I'll go back to the slides. Okay, so the next one is called Bacon.js, so it's a little bit more recent. It's a little bit lighter weight. RxJS includes observables and a lot of other things, like schedulers and timers and other things. It has a cooler logo, so I guess that's cool. They're on GitHub. Okay, sorry, maybe I should just stop there before I do the demos. Any questions so far? No? Show me the demo. Okay. Okay, so this first demo, is that font big enough? Can you see at the back? Okay, it's all right. I'll just make it. Okay, so what I've done here is at the start, I'm creating 3 different observables from 3 different types of events that could occur. And then from this, from the downs, so you can think of each of these as a list of separate events, right? So you could have downs happening and then mouse moves happening and ends happening, and usually the mouse moves happen in between the ends. So what I'm going to do here with flat map is I'm going to, usually I would pass in a single down event and then possibly do something with it. In this case, I don't really need to do anything with it because what I'm looking to do is I'm only concerned with drag events. So mouse moves when the button is actually down, right? A lot of times I've been, programming some small thing, and I'll set up a mouse down event handler, and then have some flag for, boolean for down, set it to true, go to my mouse move, check if down is true, and then do something in the mouse move. So this is accomplishing a similar, same thing. What it's going to do is it's going to take all of the moves until I hit an end. So take until is this way of controlling when you want an observable to end. So right now, I'm stopping it by using another observable, in this case ends, but you could stop it in other ways by, you can take until time, and you could take until, a predicate, so you could pass in a function that computes whatever. When it returns true, then that observable stops. And so now that I have this observable, I'm going to subscribe to it. I'm just grabbing the AJAX page Y, and I'm going to draw some points with running. So here's that one. Okay, so my mouse is down as I'm drawing. When I lift up, it's not drawing. Pretty simple so far. It's going to get a little bit more complicated in the next one. So in this one, I don't like having to type E page X, E page Y all throughout my code. I'd rather just type .x, .y. It's just a point. So I've created this simple function that takes in an event, converts it to a point object. And now all of those observables that I created, downs, at the end I'm actually mapping, calling map, and I'm passing that event that would have came out to event.point. And then what I end up with, down at the bottom is I'm going to get pxpy. So, I mean, in this case, I've only typed pxpy once, but potentially you could have a lot of different event handlers, and I'm just trying to save a little bit of typing here. So I could demo it for you, but it would do exactly the same thing as before. It hasn't changed. Okay, so number 3, same thing as before, but one thing that was kind of annoying, or one thing that I'd like to change is, right now each dot is a separate color, and I'm trying to make this paint app. I'd like to actually have the same color as I'm drawing. So in this example here, instead of creating a random color each time, what I'm going to do is every time I get a new down event, I'm going to create a random color at that time, and then every time I have a move, I'm going to attach that color to the point. Now, in this case, I probably could just have a global variable for color. That would save a little bit of space in this object. But if I was doing something with multi-touch, I'd actually have to store individual colors for individual streams. So
that's because I did this shit. This would have been so nice.
Then I'm going to subscribe again. I'm going to pull the color out, and let's see what this looks like. Okay, so I was just using the same color that it started with, whatever it happens to be. Okay. So next thing I'd like to do is, unfortunately, this is kind of spotty. At some places I don't even know, it's hard to join the lines up, but I'd like to actually have a continuous stroke. So right now I'm just sending single points through with every move. But you can actually combine 2 sets of points or more sets of points by using zip. So zip is a command that will take one or more observables and combine them together. So we're doing the same thing as before with the drags. That hasn't changed. What I'm introducing here is I'm zipping my drag with drag skip 1. So what skip 1 does is it will create another observable that's offset by 1. So you could offset by 2, and then you get some funky pattern, but here we only want.
So it's 1 behind? Or
skip 1. It's 1 ahead.
Okay.
Yeah, I think so. I'll show you some documentation after. There's some very excellent diagrams that show series of events and how they get merged or split out, or what happens to the event stream in different cases. And I found this. I think in this case it wouldn't actually matter which order they're at, because I'm just drawing a line. But I'm going to zip these together, and I'm just going to return an array of these 2 objects. I could return anything from here. I could, have an object with P1, P2 on it. And so down here, I'm now subscribing to this new stream of events, which is these pairs of points. Okay, so it's drawing lines, but there's a little bit of a problem here, which is that it doesn't actually know the difference between 2 points that are inside of the same line, or 2 moves that are in between the lines. So it's actually joining the tail of one to the line to the head of another line. So we'll fix that in the next next version of this. Okay, so here, I'm creating the drags as before. And in the previous one, I had taken the drags and zipped them together right away. But the drags here are all of the drags joined together. Sorry, let me back up a little bit. I should explain a little bit of difference between flat map and map. So what flat map does is, here I have moves, which is a list of things, right? And I'm returning this list of things. And what flat map does is it will take all the items from that list and merge them into the same list as the previous ones. So here I just have a whole bunch of points, a whole bunch of moves, regardless of which mouse down it was paired with. In this case, I've got rid of the flat part of the map. So now what I'm returning is, instead of just individual moves, I'm going to return a set of arrays. So the first time I press down and move, I'll create one array of moves. And then I'll press down and move, I'll create a second array. And so now my drags are actually a set of arrays that are chunked out. And so I'll actually be able to tell the difference between one stroke of the pen and another stroke of the pen. So this, because I'm not doing flat map anymore, my subscribe changes a little bit. So now I'm subscribing to drags. Each drag that I get here will be an array of all of the moves for one down, move, up cycle. And so here, when I create the diffs, it's only going to be those pairs of points from one point to the next for one stroke. So it's actually going to be creating quite a few of these diff observables. For every time I do a stroke, it's going to create a new one. Whereas this other previous example, it only ever created one diff, and that was for all of the moves when my mouse was down. I'm just going to stop here and say some brief words about just wrapping your mind around this concept. It took me a while to kind of understand how to formulate programs. A lot of it was, at least at the start, trial and error to see what different combinations would do. And even now, when I'm, decide like, oh, I want to use reactive programming to do gesture recognition, and I want to recognize this type of gesture. I don't jump directly to the final product. I think about, okay, I have this gesture that's maybe complicated. Maybe it's like triple click or like triple swipe, something like that. And I think about, well, what could I recognize first? Maybe I could just, recognize that the mouse is, down and up, and that's one event. And then I would build on top of that. Oh, it's down and it's moved some amount, and then it's up, and that's, a swipe. And then from that, I can build up to my triple swipe, whatever. Okay, so let's actually look at the demo now. Okay, so this is pane 5. So I lift up, and it's actually splitting those drags up and creating separate sets of pairs of points for each of them.
Can you go back into code? Because how I understood it was that the map returns an array, right?
Yeah.
I thought that's only once per between the down and up event. Like, how does it still do it all the time?
Okay, so here it's returning.
Like, what's the frame rate kind of that you get those new events?
You get the new events at the rate that mouse down and mouse move is getting called. But you're talking about like the drag events?
Well, it sounded like the drag event, you'll only get the drags as an array when you're done. Like you put it down and then you go up.
So that's the beauty of it, is that all these things, these observables are lists of events over time, and you don't have to wait for it to be done.
Oh, right, because you can do it
it's going to
anytime you
pump
want.
it through this pipeline. As soon as I get another mouse move, it'll pump it through the pipeline to create whatever kind of derivative observables I've created from the originals.
So it's going from the previous to like.
Yeah, it's all continually joined together. I haven't looked at the source code under the hood, but it has to. Okay, so that was that demo. Okay, cool. Now we're actually getting into some kind of more complex behavior, and this program I still probably could have run it pretty easily by setting up my 3 event handlers like I did in the past. But what I want to show you now is that some of the kind of more complex commands that it has. So what I've set up here is now, on top of having an initial color for each stroke, I'm going to create also this radius variable here. So that will be the initial size of my stroke. And then as I move, it's going to decrease the radius. And I'm going to take until I either lift up, or I'm going to take until this predicate returns that my radius, sorry, I'm going to take while my radius is greater than 0. Right? So, and you can actually chain other conditions on here as well. So I'm just going to demo what that looks like. So now it's actually trailing off. But also if I move a little bit, and I've waited there for a while. Okay, sorry. That's the next step. Getting ahead of myself. Okay, so anyways, it trails off. In the next one, I add another condition, which is I'm going to take until a timer. So I've set up a timer here to count for 1,000 milliseconds. And as soon as that timer is done, this set of moves will be canceled. So okay, so I can still do the same thing, but if I kind of rest there and now move, it's canceled that event. So I know that maybe this example has been kind of silly, and maybe it's not something that you would be doing in your day-to-day job, as a developer. But that example I gave at the beginning is something you might be doing. Another kind of cool example in one of the videos from Netflix is kind of this example where they were showing this drop-down menu where you have one of those like sub-menus that slides out. And if you have the sub-menu at the bottom and you want to get to, should have had an image of this, sorry. But if it slides out at the bottom and you want to get to this like item at the bottom of the sub-menu, and you go kind of across the open space, in many web apps that will actually kind of dismiss the whole menu and you never get to the sub-menu. One of the examples they were showing was how you could use some of these modifiers to the event streams like debounce and throttle and whatever to kind of like delay it so that as you move across that boundary, it keeps the menu open. Am I out of time?
No.
I had another menu, but I'm actually, I had another demo, but I'm going to skip it. I'll post it on GitHub and people can have a look at it later. But it just shows how to build up gestures.
No, demo that.
Yeah?
Yeah, demo it.
Yeah, you have our attention.
Yeah.
Okay. All right.
Sorry, I didn't mean you should stop by getting.
Yeah,
I was actually
everybody's-
going through here.
Okay, so
Yeah, that's pretty
Let
cool.
me just open all these up. It's probably good to see just another example of this, because the first time I saw it, I was like, what's going on here? So the thing that I appreciate, even though it takes a little bit of time to like get your mind wrapped around it, is that once you do, making changes to the behavior of how you're handling events is way easier. So at Smart, we do, one of the projects I worked on was a whiteboarding app for the web, and so you can use it on mobile, and you can use all the gestures, like you can zoom, and you can pinch on objects to rotate them and whatnot. And our gesture code was like 3 or 4 files of 300 lines each, and I was able to compress that to about 25% of the original code. It was easier to read, easier to modify. Okay, so got all my gesture examples here. So this first example is very simple. I'm using the touch events now. Touch events are kind of a pain in the butt if anybody's had to work with them, because instead of just getting individual events, you get this array of change touches, and then you have to go through the array, and then it doesn't look like any of your other events. So what I've done is I've kind of hidden a lot of that complexity here. So I'm calling flat map for each of these events on this process touch event, which is completely hidden, but I'll bring it up here for everybody. So process touches, what it's going to do is it's going to take in an event, and then it's going to look at the change touches. So with RxJS, you can create observables from arrays as well as from events. So in this case, I'm creating it from an array. And then I'm taking each touch in that array and just extracting the things that I care about. So I care about X, Y, and ID. So I'm returning that array, and then here I'm going to use flat map to kind of squash that array. I don't care about the array, I just care about the individual events within that array. So if I subscribe to any of these observables, I'm just going to get a stream of single touch events, X, Y, ID. Right? So now my touch events look very similar to my mouse events. And you could actually join mouse events and touch events together into a single stream and give the mouse events their own ID, like maybe mouse or whatever. And then everything looks the same. So this is a very simple program, but I just wanted to start off here, and then we'll build on top of it. So I was lazy, it's just going to spit stuff to console. Also, this little dot here is something called add touch. It's a very small library which you can use to simulate touch events in a browser on a desktop. And I know you can go into Chrome and you can use their touch thing there, but I haven't figured out how to get more than one touch, which is lame if you're trying to do like multi-touch gestures. So just to prove that I'm not lying, there's some other IDs. You can get rid of them. You can move them around after you create them. I'm not spitting out all the moves here because it would go by real fast. Okay. So that was example 1. Okay, so in number 2, instead of just starts and ends, I'm actually interested in taps now. So what a tap is, well, it's a start, and then sometime after I have that start event, I should just call that start. I don't actually do anything with the start in here. We'll do something with it in the future. But I'm just going to take one end after the start. So what that means is I have at least one start, and then when I lift up, I get an end, and that's a tap. So a simple tap will make it more complicated next time. Okay.
It's so much harder without this. Like, I sort of understand what Kevin's doing because I wrote him like some multi-touch stuff before. Sure, so I'll jump on. So I was saying that I sort of understand what the value that this brings, at least in part, because I wrote some multi-touch stuff as well, but not using any of this. And even to, like Kevin was saying, because you have those arrays, and so the reason why he has that take one method is normally you have an array of a bunch of touch points, and you can end up with duplicate touch end events depending on if things jittered or whatever, if the person's finger moved just slightly. And so in order to actually cancel those out, it's really, really hard to do without some of this stuff, or at least do consistently.
So just some notes about the demo here. Like here I actually have to double click when I'm clicking on the trackpad because I have to drop the touch event and then I have to click it again to get rid of it. So you might hear me double clicking, but this would be equivalent to like pressing down the touch and everything. So now if I put a couple down and I pull this one up, I get 3 taps, which is kind of weird. Kind of don't want that. The reason why we're getting 3 taps is because I've had 3 starts, and I haven't specified like that I want the ends to actually match the same IDs as the starts. So it's returning all of these ends take 1, which means okay, here's an observable. As soon as somebody takes at least one end, like call to subscribe. And so here, like I took the middle one and it's like, yeah, okay, I took one end and that's your tap there. So we have a little bit more work to do to actually get a real tap. So now, similar thing as before, but what I've introduced is this concept of matching ends. So I'm going to take all the ends, and I'm only going to return the ones where the start ID actually matches the end ID. And so that will get rid of that case where you have multiple ones down and you lift one up. Again, I'm going to take only one because I want a single tap. And now if we run this, I can drop a whole bunch, and I'll take this guy here, and get one tap with the right ID, and that was the first one, and that was the second. Yeah, knew that wasn't. But it's actually doing what we would expect. Okay, number 4. Okay, so we have taps. Oh, I didn't actually show the problem with this. So the problem is that you can actually wait a really long time before you lift your finger, and that's not really a tap. A tap's kind of a quick event. So we'd like to introduce timer here. So I've set my timer to be 300 milliseconds, and I'm going to take until that timer expires. If that timer expires, then this just gets discarded, and you don't get the tap event. So now I have to be a little bit quicker when I'm clicking. I won't actually be able to drop down multiple ones because it's too fast. But so I drop one, I lift up, I don't get it. If I add it and pick it up, then I get a tap event. And this would actually work if you had a multi-touch device and you were doing something like that. Okay.
Script. Yeah, that I wrote. You can do it right on there.
All right.
Yeah, that'd be cool. I was just saying you could do it right on your laptop if you use that 2IO script.
Oh yeah. I'll have to get that out.
Yeah.
To do better. Yeah.
Cool.
Okay, so what did I add here? Oh yeah, another kind of thing you have to worry about with touch events is since we're sensing our own taps, like when you click a mouse, the browser only reports the click. Well, I guess it reports the click if you move your mouse too. But when you do a tap, you actually want to make sure that it stays within a certain distance. So what I've added here is not only am I making sure that the star ID and then the D matches, I'm also checking that the distance is within a certain threshold. Because if it's moves more, then maybe I want to call that a drag or whatever. In this case, it just discards the tap. This is, again, pretty hard to demo, but I'm going to try. This time I'm going to use their touch thing. So if I drag, oh, I'm looking at the wrong page. Sorry. Okay. So now if I drag, it's not doing anything. But if I tap, and then so the last thing I want to show was how to recognize double taps. So you could extend this idea to triple taps or other kinds of combinations. The tap observable is exactly the same as it was before. I haven't changed it. I'm just building a new observable based on it. So I'm doing the same trick I did before with the paint demo, but here I'm grouping two successive tap events together. Okay, so in the console, I'll spit out both taps and double taps. Okay, so there's one tap, there's two taps. We got a double tap, even though it was a long time apart between the taps, and even though my tap is on the other side of the screen, I'm getting these double taps. So I'm closing in on what I really want, but I just need to filter it some more. So that's what the next one shows. So again, taps is unchanged from before. Now double taps, doing the same thing, but I'm going to filter it before I subscribe. So I'm using the same distance function. I just want to make sure that those taps are close together. So now, if I do a tap over here, I don't get a double tap. But if I do them in the same place, I still get extra double taps if I wait too long. I don't want those. I could go in and add, the timer to the filtering. Yeah, so I found it, it makes certain kind of code a lot easier to deal with. But this is definitely not a silver bullet. So don't be like, oh, reactive programming, it's cool, so I'm going to use it to try to do everything. You got to be very picky with what you use it for. I would suggest anything where you have different kinds of events. So in the demos I showed here today, we had mouse events, we had timers. Putting those two things together is going to get complicated. So if you have different types of events and you have custom logic that you're trying to program, give this a try. I mentioned I was going to show the cool diagrams. So this link is actually to the Java website, but for the Java version of this. But they've actually done an excellent job of showing how all of these things look. So they've broken it down into different types of operators, like combining, filtering, and they have these very colorful diagrams. That show, okay, if I have these two different streams that are coming at the same time, merge them into one. So if you have an error, you can delay the error. There's a crazy number of these. So we use zip here. So zip is different from merge in that zip, it just puts all the individual events into a stream. Here we're actually taking two individual events and putting them into a new event object and creating a stream of those. So anyways, there's tons of diagrams. They're really cool. What else? Okay, RxJS, like I said, has the kitchen sink, but there's actually some really handy things that it has. They have this idea of schedulers, which can be used to simulate events, which is useful for testing. And what's even more useful for testing is you can actually simulate them faster than real time. What I mean by that is you can say, okay, I would like a touch start to happen at 100 milliseconds and the touch moves to happen at 300 and the touch end at 500. When it goes to run the test, it will actually simulate what those times should be inside this internal timer system. And so it will run the test in like a couple milliseconds, which is nice instead of having to wait for all like the timing to work properly. Lastly, if anybody uses TypeScript, there's versions of this library on Definitely Typed. If you don't know what Definitely Typed is, it has a whole bunch of TypeScript definitions, which even if you don't use TypeScript, some IDEs will actually use those definitions to do code completion and IntelliSense for you. Okay, questions?
How did you get started in this? How did you find it?
Well,
Before you
this is
began?
going to be a little bit embarrassing, but usually I wake up Saturday morning and I'm eating cereal and watching random programming tech talks on the internet.
Okay.
So I just kind of stumbled across it.
Nice.
Can you tell us what is the difference between reactive programming and streams like JS?
Can you repeat the questions?
Yeah, so the question was, what's the difference between this and programming with streams? And to be honest, I haven't really done much with streams in Node, so I don't know, maybe you can answer a question for me, like does Node streams have some of these capabilities of like merging and splitting and
I guess
taking three
I
and...
guess it's more like the inputs outputs of the streams, right? That's just like an API that you have to respect from one stream to another, right? It's kind of the same actually. It's kind of the same.
It's a similar concept.
Well, the concept is the same for sure.
And actually, at least RxJS has an adapter for Node streams or event emitter, so you can actually kind of add on some of these things.
We have the wireless mic.
Just a quick comment on that. Actually, theoretically, there was a guy that did a comparison between those, and they are actually exactly the same, but the implementations end up being different. And so, but you can, anything you can do in one, you can do in the other. It just might be harder in one or the other. But I actually had a question too. What do you use for unit testing for that?
I ended up just using Jasmine and using that scheduler that I was talking about. There's a special test scheduler that you can use. I have some code that I can put into GitHub on how to set up unit tests for that. Question?
So you talked about some good use cases for this. Would you say would be a bad use case for this?
What would be a bad use case for this? I don't know, like building DOM. I don't know, like there's lots of just random things that you can do that really wouldn't make any sense. But
it's really close. That's what JavaScript is, right? Functional programming. That's the art of JavaScript. So things like that are cool. Don't use classes. Don't use functional programming.
Yeah. Any other questions? I had one too. How was the performance wise? You already said that.
yeah, so that was actually what
the event listeners clean themselves up, which is good because jQuery, even though it's got better, doesn't do that all the time.
Yeah, I mean. So, but you know, I did do some performance testing on it, and I mean, it was a little bit. There was a little bit more CPU use than like kind of the plain event handler way, but it wasn't so significant that I wouldn't use it in production. And the gains that you get in like ease of understanding, like ease of making maintenance easier, like the huge wins in there. Like the event, the gesture code that we have right now, like nobody understands how it works, like except for me because I wrote it like 6 months ago or whatever, and I'm leaving the company, so now nobody understands it.
It's one of those things. Don't touch it. It's magic.
Don't touch it, right? Because it might break. And it's like you gotta write code that you can feel confident in touching because requirements change or bugs happen or whatever.
Does anybody have any other questions?
How about the learning curve of it?
Yeah, the learning curve is a little steep. Like I think to get some working examples like the ones I showed here, it took me a good weekend to kind of turn on it, and then a little bit more to feel confident with it. But it's another tool in your toolbox, and it's one of those things like if you're not doing a lot of event-based programming or asynchronous programming and you don't have complex custom logic, then it's probably not going to be a lot of good. In which case, maybe you can postpone learning it until you run into a project where you need it. It's not one of those things that like, oh, you're going to have to spend like months and months before you get it.
So when you have problems, how can you debug?
A lot of the debugging that I did is I would just put a breakpoint or a debugger statement in the subscribe or inside of the map or the flat map or whatever to see what I was getting in. And then, if it wasn't what I was expecting, then I would go change, the observable that was coming into it.
So errors happen the same way, like they bubble up and stuff, not like promises where when you forget to fail, it's just gone.
Yeah, there's actually, like, I've just showed subscribe here, but you can also, there's a more complicated version where you can subscribe to, like, events that are coming in is one callback. The second callback is, like, the observable completed. And then the third callback is some error happened in the observable. That you can do error handling.
All right, cool. I just wanted to say that I think that first example especially was a pretty good testament to how hard programming is. Like that was a pretty good example to see, oh, I just want to draw a line and now I want to make them not connect and all the stuff that you need to go through in order to get that. So thanks for putting that together, Kevin. That was really awesome.
Welcome. Thanks.
Okay, so feel free to stick around, grab another beer if you want. We're going to hang out and chat for a little bit. And like I said, next month is kind of TBD what we're going to do, but we'll have something going on next month. And we'll kind of, I guess, keep yourself tuned to the meetup page and to Twitter. Coming out?